Enemy screen.
Mm.
Okay, so let's see where we were. What the? I remember we were in the middle of the sunrise file. Ah, okay, yeah. Okay, tree filter. Is it possible to make a tree filter?
Hmm. Uh, I think it depends.
Okay.
Like, if you want to do like a filter that uh, deletes like uh, all the subtrees that are not irrelevant, like relevant to the root. Like, if the root is not correct, you delete the subtrees.
Okay.
That 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 like could work, right?
Okay, yeah.
But if you want to like rebuild the whole tree by deleting like every value that is not correct.
hmm
Uh, hmm,
So yeah, let's draw this out. I'm gonna create an Excalibur session.
of course.
Honestly, it's for the benefit of the people online. Honestly, like not
Yeah.
you, but let me share this, start session, copy link. I'll paste it in I guess Zoom chat since we have Zoom right now.
How many like people
I don't
are
know.
watching the videos because I haven't like seen any like video.
Um, I know one student of mine saw your videos and he said that you blew his mind.
Okay.
As for the internet, I think not really. People would maybe like click on the video and watch for like a minute or two and then they click out.
Okay.
Yeah. But like let's say you go to your Polish Olympiad and you come back for gold medal, I'll be advertising your videos.
Yeah. Okay.
All right. Okay.
That
I'm
is
gonna
your plan.
search.
Okay. I
No,
won't
no,
tell
no,
you
no.
that
I'm
I got
kidding.
a gold medal.
I'm kidding, man. But I mean, if you do get a gold medal, I will be advertising your videos. That's not that one's not a joke.
Okay.
But I'm not like I'm doing this for you. It's not for me. Yeah. All right.
Yeah, of course.
Let's go to the right of
Uh,
the very. Remember we did the Sentinel thing. Let's go to the right of that.
yeah, I can
So
just I think. Hmm.
I'm gonna create some circles here. Do you see where I am?
Um,
I'm making circles.
hmm. Yeah, I can just like click on your profile picture and I will be like
Oh,
transported to you. So
okay. It's like Google Docs.
yeah, yeah, exactly.
Cool, cool. Okay. All right. So what you're saying is we can delete this entire subtree,
Yeah.
and it will just be the same as last time as we dealt with lists. So just visually, let's say we want to cross out. We see a node here that we don't like. What you're saying is
Mhm.
we could destroy this entire subtree,
Yeah,
and this preserves the structure of the tree still. But what you
yeah.
also said was that let's say we are deleting, let's say this one.
Hmm.
Like if we are just
Right.
deleting a single node and not the subtree, how do we fix the tree, right? That's what
Yeah,
you mean by
which
rebuilding the tree.
like which node should be like the top node right now?
Okay, so what it sounds like you're saying that you're bringing up a node, right? Someone has to replace the missing node.
Okay, but that node could have like other nodes,
Yeah.
so how to do
So,
that?
okay, so I bring this up as a theory question, not as a practical question,
Mhm.
because I just want you to think about this. And yes, you have the right idea. The idea here is that unless you're deleting a subtree, deleting a single node has consequences of the structure of the tree.
Yeah.
So if the node is gone and you still have the nodes all underneath there, who's gonna take that node? We didn't have this problem with a list because in a list, let me copy my circles again. I copied the wrong thing.
Sorry.
It says 50 push-ups. for yawning.
Yeah,
I'm kidding, kidding.
I can
Okay.
do that, but not in like. I think I could that in like two series or yeah,
Oh, oh, that's pretty good. That's pretty good. Okay, so like let's say we have a list on the right hand side here. To delete a node, let's say we delete this one, right? It's very simple.
yeah.
We just point the arrow to the next node, right?
Right, yeah.
This tree on the left, not so simple. When we delete a node, who takes its place? Like, do we point this one or this one, right?
Huh. Yeah, yeah.
So I'm not going to get into these details. You need to know this if you're training to be a software engineer for competitive programming. I don't think you need to know this. I will say that though that there are different tree algorithms exactly for this. Um,
Okay, okay.
for algorithms, usually trees have a convention. For example, you saw one that is a binary search tree where the nodes
Yeah,
are ordered in a particular way. Uh, so typically they have additional constraints on top of the structure, and that usually will clue you in as to which node should go on top.
okay.
For example, you might say a bigger node should go on top. And
Mm,
the you don't have to know this,
okay.
but how exactly does that work? So
Uh,
usually one way, I'll just to give you a picture how that might one way that this could work is we keep swapping pairs of nodes. So let's say we swap this
mm,
two and we swap this two, so that the node you're deleting is now at the bottom. And so now you can delete the subtree because the subtree just has leaves as children, and you can delete it safely without destroying the structure of the tree. Okay?
okay, okay.
So this is one way of doing it. Instead of doing a lot of swaps, you could also identify if you have mutation available, and this is where like mutation gives you more power. If you have mutation, you can just swap the values at the two memory addresses.
Yeah,
Okay, but we're not going to get into this. Uh, I'm going to show you another way to do treefold that's going to be a lot simpler for our purposes. I want your treefold to take in a base value. Whenever it sees a node it doesn't like, it replaces that node with the base value. Okay? So I'll give you an
okay.
example. Let's say oh crap, I deleted the circle. Let's say we want to filter our tree for odd numbers only. Let's say we want a tree that's only odd numbers and we see a two.
Yeah.
Uh, when you see that two, instead of deleting the node, I want you to replace that two with a base value. Let's say the base value is one.
Oh, okay, okay.
Remember last time we talked about deleting an element in a list, and you said that you just mark it as for deleted,
Yeah,
and so you can preserve the structure of the list.
that
It's
is what
something
we are
like,
doing. Yeah.
yeah, but instead of marking it for delete, we're just replacing it with a safe value.
Save by, okay,
Yeah. So you can call this a safe value, a base value. Yeah.
okay,
So yeah, I'm gonna let you work on this. Let's go back to Visual Studio Code now.
okay,
Okay, I need to use the restroom, and I'll let you work on tree filter.
okay.
All right.
I
I'm good.
did like some tasks below.
What the? I thought you said you didn't have time.
Yeah, I didn't. I did that like an hour ago
Oh, damn. Okay, you're very efficient. All right.
when
Okay,
I
work on tree filter
yeah.
first, and I'll come back from the restroom.
Okay. Yeah.
All right.
Um, that. Um, for the guys on YouTube, I'm just copying stuff from uh, the previous file. Then was declare. Yeah. Okay. So it's volume. Should be blue and oh, that's nice. Where's the template?
Okay, I'm back.
Oh, hello again, hello again. Welcome back.
Thank you, thank you.
Uh, okay. We should write tests first, right?
Hmm.
Mm, mm, hmm. That's fun. It's shoved up. What am I? I told you that I am tired, right?
Hmm.
I don't know what I am writing. Uh, I don't know. Mm, it should be also because nothing happens. Okay, three filter off. Mm, hmm. This will return like T1, uh, and this, but I don't know if not this. Uh, this node of zero leaf. Mm. What do I have here? Mm. Mm. Also this. Okay. Uh, oops, node of it's three, right? So it's zero leaf, zero, no, uh, zero, zero leaf, no, zero leaf, no, zero leaf. I think it's correct. Mm, uh, okay, and mm, the value then is the value and the filter on of last. As it's going to. Hmm, I
Oh,
did something wrong.
is it?
Uh,
Looks okay. Right, right, left, left.
oh, I didn't delete this,
Oh,
right?
okay. Yeah.
Or no, it doesn't still work.
Oh,
What what
oh, that's
operator evaluates constructor? What is operator?
oh,
Link. Did I use link?
yes. Brain fart. Yeah, same. I didn't spot that either. Idea's right though. Nice. Okay. While we're here, one thing I would notice how lines 240 and 240 are like very similar, and they're
Yeah.
different in one way. Is there a way we can tidy this up?
Ah, do you want to? I can. I want to leave it as it is. Yeah.
Wait, why?
Really. We can like make
Do you see what I mean though? Like,
yeah, yeah. Can you like make a function?
no, no, no. We don't need to make a function. It's very simple. Okay, so I will demonstrate for you once, so you can apply this idea in the future.
Uh,
So first, uh, remember the abstraction recipe? When you have multiple
yeah,
things that look similar, first you take one of them, you copy it,
yeah.
and I'm going to put it below, and you paste it. Next, you take what's different. So here, the first thing is different, and you put dot dot dot. Next,
Mm,
you turn that into instead of a parameter, I just say a variable. Let's call it
mm.
current value, or new value.
Yeah,
And a new
sounds
value needs
better.
to come from somewhere. Okay, where's new value going to come from?
Okay.
So it's this, right? If
Yeah.
it's value, otherwise it's base, right?
Yeah, makes sense.
Oh, but no closing semicolon. It should be
Yeah,
and.
you and yeah, right.
Okay, now if we run this, let's see. Okay, so this is a
Okay.
pattern that you can apply in the future.
Yeah, okay.
The reason why this is important is because you want to eliminate. I got kicked out from the session.
Oh,
I lost connection
okay.
to host.
You didn't like make changes in. Can you
Wait,
just oh, you didn't copy the code,
no,
right?
I did not call. Wait, shit. Wait, was I not typing anything at all?
Yeah, I was just looking at your stream.
Oh, bro. Okay. Wait, you saw what I wrote still though, so you can do it
Yeah,
yourself
yeah,
now.
yeah, yeah.
Perfect. I planned it this whole time. Okay, it's now your turn to write it.
Okay, okay. Can you see?
Yeah, I'm still joining.
Okay, I can just change it while you were joining.
Yep.
Right.
Huh. I
Uh, we hate Visual Studio Share, right?
Could you restart your session? I can't seem to join.
Oh, of course.
Yeah.
Mm, send you new
Okay.
link. Mm,
Okay. Let's see.
yeah,
Summarize.
I did it.
Nice. All part of my plan.
Mm,
Yep. And let's run it. Let's see. Nice. Okay. So yeah, we just did a refactor. Notice how we can apply the abstraction recipe even though we are not creating a new function.
Yeah.
So for you, I didn't go through it, but I do like I would normally show other ways to practice the abstraction recipe. There are other ways to actually abstract other than making new functions. In this case,
Okay.
we just make a new variable. And the reason why this is important is because you want to eliminate code duplication. For competitive
Mm,
programming, sometimes you're working on something and you're a little bit off. And let's say you got
yeah.
like duplicated code and you realize the fix to one of the cases and you fix the one case, but you didn't apply the changes to the other copies of the
Yeah.
duplicated code. Now you got problems, right? So tiny things like this will make a huge difference. It cleans up your cognitive space. You're thinking more about the problem rather than your code, right?
Makes sense. Makes sense.
Yeah, yeah. And also that was like less than 5 seconds, right? You could have done that with your
Yeah.
eyes closed. Yeah. Okay, so let's look at what you've did. So I saw threefold, and I'll use
Yeah.
the folder for this.
I
Nice.
didn't read the whole comment that you have wrote, and I did in the test. I did like other functions first. Yeah.
Oh, that's fine. This looks okay.
Yeah. I did like them later though.
Mm. Anyway, yeah, so this looks like your standard folder with lists, right? You have your
Yeah.
base, it's X, Y to
Com
Y. Well,
combine.
combines X, Y, Y to Y because you got one extra
Yeah.
thing. Yeah,
Yeah.
so no, very standard stuff. Okay, let's look past folder. So let's see tree height. Okay, looks good.
Yeah. That's the same as. Yeah.
Folder. Reverse
Reverse was
VLR.
really easy, right?
Mm, nice. Yeah. Flatten fold. Uh, L dot append VR. Yeah.
Yeah. Like
Okay.
the same as. Yeah.
Tree map fold. XY, tree Y. Node operations VLR. Yeah, looks good. I normally would tell you to do tree like implement filter with fold,
Okay.
but I think you look like you know what you're doing. So
Yeah.
I'll let you skip that for now, but you're welcome to do that at your own time.
Okay. I didn't do and like the last two tasks.
Oh, okay.
I okay. I know how to do like is balanced, okay, but I
Yep.
don't know how to do tree diameter.
Uh, okay, let's just jump past the tree diameter then. Let's do that together.
Okay.
It's the same principles, but a little bit more stuff. So I'm gonna stay quiet and let you figure it out.
Nah, man.
So yeah, just follow the design recipe, work on your test cases, apply the template, all the basic stuff, and you'll find that you'll naturally arrive at a solution.
Okay, what was the okay the length of the longest path between two nodes. Okay, path does not have to include the root, and the nodes cannot show. You missed a letter. Show up in the path more than once.
So my advice is just follow the design recipe, have the signature, write the function
Mm,
header, and then go straight to tests to get intuition on a problem.
yeah. Okay. Uh, okay. No. Okay. What should it return? Uh, where is it? Okay. Design 3D. Huh. Hmm. Okay. Can I just like I will copy that because I don't want to scroll every time.
Okay.
Uh, okay. No, okay. Hmm. Uh, how does it like differ from like the height of a tree? I don't understand.
Okay, so let's start with the simplest test cases first. What's the simplest
Okay.
test case?
Like uh tree like empty tree like
Okay,
yeah. So leave right. So mm, it's zero,
okay,
right?
cool. All right, what's the next simplest test case?
Next simplest test case. Like it shouldn't include the root, so
No, it does
uh,
not have to include the root. It can, but doesn't have to.
doesn't have to. Okay. Hmm. So it won't. Okay, it won't. So it's still zero
Wait, why is T1 zero?
because it doesn't include the root.
No, no, it can include a root, but doesn't have to.
What do you mean?
It's optional. You can optionally include the root. So if adding the root adds more length, then you should include the root. So in this case, T1 is the root node, right?
Yeah.
It helps you to add the root node, so you should add it. So you should have length 1.
Okay.
Yeah.
Okay. I'm getting scared, but that's all right.
Yeah. No, I think you'll find that this is actually a very simple problem.
What's that? You call this very simple problem?
Okay, it's not maybe I'll say it's a medium problem. It's a step up from what you did previously. Okay, so I actually want you to do one thing that's a test case that's one level simpler than this. What's one test case that's one level simpler than this?
With one uh children, right?
Ah, one child, right? Yeah.
Wait, one child, one child. Yes, yes.
So yeah, we have two nodes
Correct,
now.
correct English, right?
Yeah, plurals.
Uh, so I had to look up. This is two, right? You
Okay,
can't.
why is it two?
Uh, because it's the longest path between like all the nodes, right?
Okay. Yeah.
Uh,
So if you go from child to root, that's length two, right? Two nodes.
yeah,
Okay,
yeah.
great. Okay, how about the next test case? What's the diameter of that?
Is it uh, is it two?
Okay, why do you say two?
Because it's also like the longest path.
So what are the nodes in that path?
Like the tree is the root, and then on the left we have like a node with one, and on the right a node with two.
Okay. So what would a path, what's an example of a path that's the longest path?
Like from like I don't know, one to three, or from three to one.
Well, you gave me three numbers, so wouldn't that be length three?
What?
Okay, wait. Let's jump to Excalibur.
Yeah,
Uh,
of course.
yeah,
I have
eventually you
it.
understand the problem. Okay,
Okay, yeah.
so let's
I,
say,
I don't think I am ready. Like
let me,
maybe I just
oh
don't
crap.
know like the words.
Sorry, let me move all this stuff away. Okay, so let's say we have our, let me label this. Was like three was the root, right?
Yeah, three and then one, two. Yeah,
So
right.
what is the path you were saying just now?
Like from three to one. Can you see my mouse? So I won't have to.
Yeah. So three, two, oh, 3T01. Sorry, I misheard you. Okay, so you're saying this way?
Yeah, yeah.
Why do we have to start from three?
Okay, so it doesn't matter from one to three is
One,
okay.
two, three? Okay, but why not go like this?
Okay.
Like, why not, right? It's not illegal.
Mm. Uh, okay.
Yeah. So the answer for this graph is actually three.
Three.
Yeah. Because we can go one, three, two, for example.
Yeah, or two, three, one.
Okay, so the idea here is you can actually traverse from a lower level to a higher level. That's legal.
Ah,
Yeah.
okay. It gets even harder now.
Oh, I got disconnected from the session.
Again?
Yeah. Sorry, can you restart your session and send me the link?
Of course, why not?
And then while we're at this, once I get the new session, I'm gonna restart the Zoom session as well since that's gonna expire.
Yeah. Okay. Uh, did you get the
Yeah.
new? Okay. So I guess see you soon.
Hold on, let me make sure I join the session first. The link
Yeah.
you sent me, it still didn't work. What the hell?
What?
Okay, I think that's fine. I think I'll just ask you to screen share later.
Yeah?
Yeah, I think maybe your network connectivity is unstable, or maybe like just our locations are far apart. I'm gonna restart the Zoom session and I'll send you a new link on Gmail, okay?
Yeah, of course.
All right. Okay, damn, your
Okay.
theme is nice. All right.
It's it's my favorite team actually. On my other laptop with like Linux, I have it like all over my system with every app, like every app that I am using, like literally every app.
Wow, that's nice.
Yeah, that's crazy.
Nice.
It's named Cat Pushing Mocha. If
Cat
that
pushing Mocha.
yeah.
Nice. Yeah, it's a nice theme. I like the light purple.
Okay. I understand the problem now.
It all makes sense now. Yeah, okay. Uh,
Ah.
I recommend making one test case where where the path doesn't involve the root.
Uh, Okay. Okay. So like I must create like an example, right? Hmm. Uh, how to call it? When okay, so this like should be it. Like
Okay.
I hate copying this because
So what's the
wh- when
longest? Mhm.
when it has like hyphens, I can just double click it, right?
Oh,
If it has underscores,
that's interesting.
I can just double click it or just copy it with Control Shift and then left
Huh.
arrow.
Interesting.
Yeah, so that is why I hate hyphens.
Oh, okay.
There is a reason I don't hate it like without a reason. It's three, right?
Okay. I don't think this is a clear case because you can argue
Mm.
that you go from the root to number two to the child of number two.
Oh, okay. Okay.
So yeah, how do we make it less ambiguous so that there's only one choice which doesn't go through the root?
Uh, hmm. Can we just like
Yeah. I mean, you could also reuse an existing example, but that works too. So it's two.
so okay, what is the length of that? One, two, three, four, five. Is it five? I think it is. I think it is.
Okay. And what's the
Uh,
path? What's the path of that?
like, mm, oh, it is. Wait. Here. I'm just visual. I'm making the tree in my head.
Okay.
Uh, okay, it's four, right? Because
It's
it goes
four.
from
Yeah.
here to here and then here and here, right?
Yeah.
Yeah. Okay. Uh, okay. So,
But arguably, it's not. Okay, that's okay. It's okay. It's arguably not ambiguous. It could still go through the root, but that's fine. I'll accept this.
what will be like the test that's
So I would
what?
make T the rightmost T2 right leaning. So have a T2 have a child on the right. So that way, instead of going from two to root, you would go to two
Oh,
to T2 for sure.
okay, makes
Yeah.
sense.
But it's okay. It's okay.
Mm,
You can keep with the function.
okay. Uh, hmm. Okay, so one, two. Okay, so we have like only three options, right?
Okay.
That uh, if the path, the longest path is like from from left from left through the route to the right, right? That is
Okay.
the first case. The second is that uh, it's like hidden in the left child, and the third is that it's hidden in the right child, right?
Okay.
And in the end, we just calculate like the maximum of these three.
Sounds good. Okay. Let's do it.
Okay, so how to spell true? TH.
Eh,
Yeah.
Yes, yes.
Okay, so it will be three heights. I see of what I am doing. Of left plus I need to learn how to type on my keyboard.
Yeah, same.
That is like pretty important thing to learn when programming, right? And
Yeah.
should we add one, right? Because of the root?
Okay.
I think so. Uh, and then okay, I mean I can just call it enough. Uh, it should be like three diameter of left. Mm, right. Uh, just calculate the max. I created a function named max. Okay, it's great.
I see.
I I don't need to remember the library name.
I see.
Did I? When using this, I named it like F and R. So
Ah.
yeah. Okay,
Ah,
it is
congrats.
working.
Nice. So this is pretty good. There is a so notice how when you do tree height, and you do tree diameter, you're traversing the same subtree twice. See that?
Uh, yeah.
So one thing you can do is you can combine. You can calculate the height as you're trying to find the diameter at the same time.
Okay,
So what that will look like is when you do tree diameter, it returns. You create a version of tree diameter that produces the diameter and also the height. Okay.
but mm, I would have to like use the tuples. So and
Yeah.
tuples are pretty weird looking in this language.
You can also create your own struct, your own data, if
Mm,
that works too. Uh, I will leave that as an exercise for you if you want to do that. I'm not sure if competitive programming will like expect that of you, but I think it's a good exercise. But for now, let's move on from this. Okay, yeah, good work. But do you notice like when you first approached that problem, it was kind of daunting?
yeah, because I didn't understand it. Okay,
Oh,
when
okay.
I didn't understand like this.
Hmm.
Like it's good that in competitive programming I have an example or
Ah.
like of the on the function, right? What it
Hmm.
should like return when given like the input, right? With the given input. So that kind of helps, right?
Yeah. But yeah, in my sessions, I do ask you to create examples to help you think through the
Yeah, yeah.
problem more carefully. In competitive programming, I guess it's a bit of an advantage to give you examples. However, I would argue that it's beneficial for you to create smaller examples for yourself.
Yeah, yeah, always to
Yeah,
see how it works.
exactly. Yeah, it's easier to think through
Yeah.
as well with smaller things.
Mm, yeah.
All right. For your next problem, I would like you to okay, let's go to Excalibur real quick. S-
Okay, of course.
Are you able to share Excalibur? Okay, great.
Yeah,
Okay. Uh, I trust you that you're not going to click on the Gmail top left. A- And if
I'm
you
not
do, I
going.
trust that there's nothing sensitive on it.
I it's like
Don't click on it, don't click on it.
why?
Okay, okay. Dude, I get very scared, like, because I don't know what's on it, like,
Okay,
yeah,
like
just,
I
okay,
knew it was like opened
okay,
on your sessions.
okay.
I don't
All
think
right,
they're going like to hack me or something
okay,
through my Gmail.
all right.
Just kidding.
Okay. Do not test the internet. All right. So for your next task, normally I'll write a statement for you, and I'll ask you to process that statement. But
Hmm.
I want to focus more in the new technique I'm about to go through, so I'm just going to show you an example and I'll explain the problem with this example. I would like you to create a function called find. Wow, that's a very small. Wait a why is my font so small? Is it because everything's so big? The hell? Sorry, let me shrink this down. And now I'm going to add a text that's hopefully bigger in size.
Oh, the now the arrows look like crap when they are so small.
Yeah. Okay, so find node to root given a tree, and you will produce a list of
Mm.
for you, I'll do a list of value. So in your case, number. So let's say we are trying to find. I'll give you an example. Let's say we're trying to find six. Oh, sorry, sorry.
Well,
You need to
yeah,
also take in the
I
number.
was
Sorry, my
yeah,
bad.
yeah,
So another version of this problem is you actually take in a node, but
right.
in competitive programming, I don't think you take in nodes. You're gonna work with numbers strictly, so we're not gonna do that. So let's say you're trying to find six.
6. Okay.
It's gonna produce 6, 3, 1.
3.
Wait, sorry, that's a five.
Yeah,
My
it's a 5.
handwriting
Right.
is a five.
Okay.
Sorry, is it produce this list 6, 5, 1, 3? Oh, um, yeah, and a restriction is that must run in O of n. Must run in O of n, where n
Okay.
is the number of nodes. So basically, you can only see each node a constant number of times. Okay, does this make sense?
Yeah, I guess so. Uh,
Uh, Actually, I want to change one more thing. Actually, while we're here, I want to show you this. It's gonna, if you do not find the node, it's gonna produce none. So if you go to the pirate documentation, there's a thing called an option. Read
hmm.
up on it. Basically, an option, it wraps your value. It will
Okay.
either produce something or nothing. If it's something, the sum has the value. If it's nothing, it's just none. Okay.
Okay.
So for example, let's say another example, we are trying to find 100. It should produce none. And then we fix the previous test case. It should produce something of list. Okay?
What? Okay.
Yeah.
The professor really thought about this.
Sorry, what?
The professor, like the person that was making the language,
Talked about this?
taught, like thought. So
Oh, yeah, yeah.
like the pa past tense of think, right?
Yes, yes, yes. I see what you mean. Yeah.
Yeah.
Yeah, I mean, it's a common pattern. A lot of functional languages have this. C++ has this actually. It's std option. Is it std
Yeah,
option? I think it's std option.
I think so.
Uh, but in C++, you may also sometimes use the idiom that you return null for nothing
Yeah,
if it's a pointer type. But sometimes you might specify a certain value to represent none. For example, let's say a number, you say zero is none.
okay.
You might see that also, but here it's explicit. And the reason why it might be beneficial to be explicit is, let's say you say zero, it means none. Let's like for example, let's say like okay, for say let's say empty list is none. For example, right? That's a totally valid interpretation. What's the difference between none or an empty list? You see that?
Yeah,
There is no difference. We squash
yeah.
the two meaning together. So sometimes it might be beneficial to squash them for maybe performance reasons. You allocate less memory.
Okay,
Other times it might be beneficial to be more explicit so that people don't get confused and there's less chance for bugs, right?
okay,
All right, so we have 3 minutes. We'll do what we can. Let's go back to UVS Code now.
of course.
But I
Uh,
mean, yeah, if you can do this at your own time, that's great. If not, we'll pick this back up tomorrow. But yeah, let's see.
I think I can do that. Like,
Okay.
I think I can do that like today.
Wow, today. Okay.
Today, right? Can you see my time?
9:57. Yeah.
Yeah. Okay, so I can just copy the sentence. I don't know. Wow, my mouse is something scrolling down. Sometimes scrolling down when I'm scrolling up. It's like a common problem with this model.
Interesting.
Yeah, I don't know why though. It's Razer Viper V2.
Damn. My mouse is a $1 ThinkPad mouse.
Really?
Yeah. It came with my
Oh,
laptop.
uh, okay.
But I don't have
So
any scrolling problems. So
that
I
is
win.
great. Yeah, I think so. Like definitely, right?
Oh,
Um,
shit, sorry. It should be called Find Path to Root. I think I brain farted.
of course,
Sorry, my bad. There we
of
go.
course. Uh, mm, uh, okay, something I will complete that later when I learn about option, right?
Okay.
Okay, okay. Uh, so can I create like this tree? Yeah, I
So
will.
this string?
This
Oh yeah,
tree.
sure. Yeah, if you like,
Yeah.
yeah.
Uh,
This is why I don't like giving examples, man. I give you a free one.
yeah.
Okay.
So
All right, I gotta run to my next session. I wish
of
you best
course.
of luck.
Thank you.
Good
Like,
luck.
see you tomorrow. See you
All
tomorrow.
right, see you tomorrow, Simon.